All right, ladies and gentlemen of algebra, moving on from Unit 6 Notes 3. Unit 6 Notes 3 talked about exponential growth. Now we're talking about exponential decay. So decay is exactly what it sounds like. Everything is getting smaller and smaller and smaller. So that's kind of what decay is talking about. So instead of adding, what you're going to end up doing is doing subtraction. So when you look, your initial amount is still C. That doesn't change. But your rate of change, instead of adding like you were before, now you're going to do some subtracting, and this time t is still your factor of time. So the only big difference is this subtraction here. That's the only big change. Now you're subtracting a rate instead of adding a rate. It's a really small thing that you got to be very, very careful with. Make sure the problem says growth or decay before you know what you're doing, then make sure things right. So if I look here, so my equation, C is 16, R is 0.45. So my equation here is going to be then this. So my equation is going to be 16, 1 minus 0.45 raised to the t power. So start filling in your blanks here. What does this look like? Well, if I go -1, 0, 1, 2, 3. And if you guys are clever with the graphing calculator, come up, I can show you. Your graphing calculator can do a lot of this for you. So back up here, 16, 1 minus 0.45 is just 0.55 raised to the power of t. So if 0.55, if I start with -1 times 16, I'm going to start at 29.09. So then 0 is going to be at 16. At 1, this ends up being 16 just times 0.55. So that's going to be at 8.8. Okay, 0.55 squared to the second power times 16 is going to be 4.84. And this last one, remember, all I'm doing is taking 0.55 raised to the power. So here I'll take it to the third and then multiply it by 16. So this becomes 2.662. So when I go to graph this, I'm looking at this going, okay, at -1, I'm all the way up at 29. At 0, I'm at 16. So at 0, I'm right in there at 16. At 1, I'm down here at 8.8. At 2, I'm at 4.4. And at 3, I'm at 2.62. So you can start to see how this is going to kind of go. It's going to come down, then it's going to bottom out pretty hard right there. All right, so that's going to be what that graph's going to look like. Here, C equals 15, R equals 1/3. So equation is going to be 15, 1 minus 1/3 to the power of t, or power of x, whatever you want to call it. So 15 times 2/3, or 0.6 repeating in a calculator, to the power of t, or power of x, whatever. So if I go -1, 0, 1, 2, 3. So -1, this is saying 15 times 2/3 to the -1. But -1 means flip it over. All right, so 2/3 flipped over is going to be 3/2. Times 15 is going to give me 45 divided by 2, which is going to give me 22.5. All right, so then this is just going to be 15. Then this is going to be 15 times 2/3, which is just going to give me 10. This one's going to be 15 times 2/3 to the second power. Times 15. So that's going to be 6 2/3, or 6.6 repeating. And if I take 2/3 raised to the third power times 15, that's going to give me 4.4 repeating. So at -1, I'm at 22.5. At 0, I'm at 15. So at 0, I'm right there. At 1, I'm at 10. At 2, I'm at 6 2/3. And at 3, I'm at 4.4. So this one's not going to be quite as steep, but it's still going to follow that same kind of reasoning right there. Okay, so let's take a look. A fully inflated raft loses 6.6 of its air every day. The raft originally contains 4,500 cubic inches of air. So anytime they give you a big number like this, so they give you a big number like 4,500, that should be your dead giveaway. That's going to be your initial C. All right, so then 6.6, that's going to be your rate. So write an equation to represent the loss. There should be write an equation. So this is going to be how much air is in there. So it's going to be initial amount of 4,500, 1 minus 0.066 to a factor of T. Okay, so when I throw this in there, 1 minus 0.066 is going to give me 0.934. So after 7 days, well, I take 0.934 raised to the 7th power, and I multiply it times 4,500. So 0.934 raised to the 7th times 4,500. So after 7 days, it's only got 2,790.23 cubic inches of air. So here, during the past several years, the population of Campbell County, Kentucky has been decreasing at an average rate of 0.3% per year. So the population was 88,647. Figure out the population 13 years later. So T is going to be 13 because you go from 2000 to 2013. C is going to be this 88,647. Your rate is going to be 0.3%, but remember that's as a percent. Your actual rate's going to be 0.003. So you're going to have 88,647 times 1 minus 0.003 raised to the power of 13. So 1 minus 0.003 raised to the 13th power times 88,647. So 85,251.3. So approximately 88,251 people for 13 years. So during an economic recession, a charitable organization found that its donations dropped by 1.1% per year. The donations were 390,000. So how much is it going to be 5 years later, 5 years after, especially if nothing changes with the recession? So 5 years, there's your time right there. 390,000, that's your initial amount, that's your C. Your rate is 1.1%, so as a decimal, that's 0.011. So when I go to do this, it's going to be 390,000, 1 minus 0.011 to a power of 5. So 1 minus 0.011 is going to be 0.989 raised to the 5th power times this, 390,000. So when you get there, you end up getting $369,017. That's what your answer ends up. All right, take a look here. Are these going to be growth or decay? Your dead giveaway is what's being raised to the power, okay? What's being raised to the power? So if it's a positive number being raised to the power, you're fine. If it's a fraction or a decimal, that's going to be decay. So here, the 7 is being raised to the power. So that's going to be growth. Here, the 4 is being raised to the power. Don't get tripped up by this 1/2. It's the 4 that's being raised to the power. That's still going to be growth. Here, the 2/5 is being raised to the power. That's decay. The 0.75 is being raised to the power. That's decay. I don't care that there's a 2 and there's a 3 here. All I care about is what's being raised to the power. So that's 5, so that's going to be growth. All right. Smile and be happy that when all your work is done.